Hello students, in the previous section we have discussed indirect methods for measuring large astronomical distances. Here in this session we will discuss some indirect method to measure extremely small distances. I mean to say atomic distances. There are some instruments available to us like electron microscope which can measure distances of the order of atomic distances of the order of 10⁻⁻10 meter, right? But let's discuss some indirect methods. We will start with Avogadro's hypothesis. By using Avogadro's hypothesis, we can easily determine the size or rather the radius of an atom. We can estimate the order of its magnitude, right? So let's discuss that. So we'll discuss Avogadro's hypothesis. So this hypothesis will be used by us so as to determine the radius of an atom, right? So first let's discuss Avogadro's hypothesis. We are aware of the very basic thing that atoms are spherical in shape, isn't it? So when a large number of atoms are put together, obviously there must be some empty spaces left between them. So atoms are considered to be spherical, like this. So when a large number of atoms are put together, a substance contains a large number of atoms, so when they are put together, then empty spaces are left between them. These are the empty spaces which I have darkened, right? So Avogadro's hypothesis states that the net volume occupied by the atoms in 1 gram of a substance is equal to 2/3 times the volume of 1 gram of the substance. So I'll write it. Avogadro's hypothesis states that volume occupied by the atoms in 1 gram of a substance, it is equal to 2/3 of volume of 1 gram of the substance. So this is Avogadro's hypothesis, right? So by making use of this hypothesis, we can determine the radius of an atom. So let's do it. We consider an atom. Suppose its radiuses are, then the volume of an atom would be given by 4/3 pi r cube. That's the formula for the volume of a sphere, isn't it? Now let us consider a substance of mass m gram, right? Also let us consider its molecular mass be capital M. And we are aware of the concept of Avogadro's number, isn't it? It is equal to n. Avogadro's number is n, which is equal to 6.023 into 10⁻23 atoms per mole. Atoms per mole means 1 mole of a substance contain atoms equivalent to Avogadro's number, which is 6.023 into 10⁻23, right? Also let us consider the substance which we are considering. Let its density be rho. Density of the substance, suppose it is given to be rho, right? So let's calculate the total number of atoms present in m gram of the substance. Now as per the molar concept, capital M, which is the molecular mass, in this gram, m gram of the substance, capital M gram of the substance will contain this much atoms, which is equal to Avogadro's number, right? I'm writing over here. N gram of the substance will contain a number of atoms equivalent to Avogadro's number. 1 gram of the substance will contain atoms equal to n by m. N is the Avogadro's number, m is the molecular mass. Therefore, small m, gram of the substance will contain atoms which will be given by n by capital M multiplied by small m. So students, if the mass of the substance is considered to be small in gram, then in this amount of the substance, the number of atoms present would be this much, right? And volume of one atom, as I have told you, it's 4 by 3 pi r cube. Therefore, volume of the atoms in m gram of the substance, it would be equal to total number of atoms present in m gram of the substance, which is capital M small m over capital M, multiplied by the volume of each individual atom. An atom of radius r will have a volume of 4 by 3 pi r cube. It's clear now? So, in mass m, in mass small m of the substance, total number of atoms present are given by this particular expression. Now what to do is, let's substitute this value over here. Let's make use of Avogadro's hypothesis. So, substituting this value over here, what do we get is nm divided by m into 4 by 3 pi r cube. It will be equal to 2 by 3rd. 2 by 3rd of volume of 1 gram of the substance. Here we are considering mass small m of the substance. Mass of the substance, it's equal to volume into density. So volume would be mass divided by density. So mass of the substance is considered to be m and density of the substance is considered to be rho. Clear? So we have used Avogadro's hypothesis, which states that the total volume occupied by the atoms in a given amount of substance is equal to 2 by 3rd of the volume of that particular substance. Right? Now let's solve it. This will get cancelled. So 2 over here it will come to be 2. So r cube, it will be equal to capital M divided by 2 pi rho n, or r is equal to capital M divided by 2 pi rho n to the power 1 by 3. So this is the formula which we use so as to find out the radius of an atom, and its order is found to be about 10 to minus 10 meter, right? So knowing the value of the molecular mass of the substance, which we are considering, density of the substance, which will be known to us, Avogadro's number, it is 6.023 into 10 to 23, and substituting these values over here, we can easily find the rough estimation of the size of an atom. So students, this is an indirect method in which we have made use of Avogadro's hypothesis so as to estimate the size of an atom. So this is the first article. Now there is another interesting method. That is, we will try to find out the size of the molecule of a liquid. In order to find out the size of the molecule of a liquid, we will consider the case of an oleic acid. So students, why I am making use of an oleic acid? Because in oleic acid, the size of the molecules is quite large. So it will be somewhat easy to determine the size, or rather the diameter of that molecule, right? So second is, we will try to find out the size of a liquid molecule. We will try to find out the size of a liquid molecule, and we will take the case of an oleic acid. As I told you, we are considering oleic acid because the molecular size is quite large as compared to the other molecules. So a solution of known concentration of oleic acid is made by dissolving it in alcohol, right? A solution is to be prepared. A solution of known concentration is to be prepared. Suppose, let's see, a solution of concentration 1 by 500 is to be made. Let us assume a solution of concentration 1 by 500 is to be made? Obviously by combination of oleic acid and alcohol. So 1 by 500 concentration. What I mean to say is that 1 centimeter cube of oleic acid is to be dissolved into 500 centimeter cube of alcohol, so as to make a oleic acid solution of concentration 1 by 500. So that is the process. So let's say we have made an oleic acid solution, right, of concentration 1 by 500. So that's the method. Now what to do is, we put few drops of this solution over the surface of water, which is contained in a flat, broad vessel, right? So I repeat, what we do is, we will put some drops of oleic acid solution on the surface of water, which is placed on a flat, broad container or a vessel. And then the film of the oleic acid solution is stressed very, very carefully. And after some time, after the passage of some time, after the elapse of some time, what will happen is that the alcohol in the solution will get evaporated. So we will be left only with oleic acid. Now, by using tracing paper and graph paper, we can easily determine the area of the film of the oleic acid, right? Suppose that area is A. Suppose that area is A. Now, if we consider N be the total number of drops which is poured on the water surface. Now listen very, very carefully, right? So, volume of 1 drop of oleic acid solution, suppose it is equal to V, right? Let us consider it to be V. Therefore, volume of 1 drop of oleic acid, alcohol gets evaporated, so I am talking about the volume of 1 drop of only oleic acid. Concentration is 1 by 500. So if the volume of 1 drop of oleic acid solution is V, then the volume of 1 drop of an oleic acid would be V by 500, since its concentration is 1 by 500. Understood now? So suppose N drops of oleic acid is poured on the water surface, then volume of N drops of oleic acid would be NV divided by 500. This will be the volume of N drops of oleic acid. It's clear? Now what to do is, as I told you, once the alcohol gets evaporated, we will be left only with oleic acid, and its film will be formed, which is very, very thin. And extreme care should be taken that the film should be stressed, right? And the area of that oleic film can be determined by using tracing paper and a graph paper. Suppose that area is found to be A, and the thickness is suppose T. Then the volume of the oleic acid, which is poured over the water surface, that will be given by A multiplied by T. Cross-section area multiplied by thickness. T is the thickness, and it will be equal to NV divided by 500. So what I mean to say is that this is a broad vessel over which water is poured. This is water is poured over here. And when oleic acid solution is poured over here, few drops of oleic acid solution, and it is stressed, and if it is left off after some time has passed, the alcohol will get evaporated. So a film of oleic acid will be formed on its surface. Suppose this is the film I am talking about. This is the film of the oleic acid. A small film of thickness thickness equal to the diameter of the molecule. So this is considered to be of thickness T. And I am talking about this cross-section area. This cross-section area, this is A. So what will be the volume of this oleic acid which is poured on the water surface? That will be A into T. And also using this concept, the volume is NV by 500. So you can equate these two. So what you get is T, it is equal to NV divided by 500A. Over here, N is the total number of drops of oleic acid solution, right? V is the volume of one drop of an oleic acid solution. And A is the area of the oleic acid film. T is the thickness of this particular film. Now observe this diagram. The thickness of the oleic acid film will give an estimate of the size of the molecule. So this P will give an estimate of the size of an oleic molecule. So student, this is a very, very important concept, right? So this is an indirect method so as to find out the size of a liquid molecule. I hope you have understood this topic. Read it thoroughly and we'll cover the next topic in the new session, in the next episode, right?